In this video, we're going to solve the problem on the joint probabilities. It's a very interesting problem because it reveals some structural and conceptual issues connected with the joint distributions. So let's say we have an unfair die. It's unfair because probability of getting an even number each time is higher than probability of getting an odd. So probability of getting an even number is 2 over 9, and probability of getting an odd number is 1 over 9. So please note that we have kind of 9, the weight of all the numbers, all the outputs is equal to the 9. So the total weight is equal to the 9, and it's distributed over the different outputs differently. So we have two more random variables. So we have x, it's equal to the 1 if the output is an even number. So even numbers is meaning 2, 4, or 6. And 0 if the output is equal to an odd number. It's going to be 1, 3, or 5. So, and we have another variable y is equal to the 1 if an output is greater than 3, strictly than 3. So they are 4, 5, or 6. And it's 0 if it's less or equal to the 3. So the outputs are 1, 2, and 3. So what we need to do is we need to create the joint probability distribution table for the x and y. So first of all, let's find the probabilities for x and y separately. So the probability of x is equal to the 1 is equal to 2, 5, 4, 6. It's basically we need to look to this table. What's the probability of getting 2? It's 2 over 9, right? So we can write down the probabilities here already, right? So probability of x is equal to the 1 is going to be 6 over 9, and probability of getting 0 is going to be 3 over 9. And again, probability of getting 1 here for the y, it's like basically more than 3, right? So probability of getting a number which is more than 3, it's going to be 5 over 9. And probability of getting a number which is less or equal to the 3, it's going to be equal to the 1 plus 2 plus 1 is going to be equal to 4 over 9. So what we need to do is we need to create the joint probability distribution table, basically the table which contains all different combinations of the x and y together. Basically, we need to find the probability of x is equal to the 1 when y is equal to the 1, or probability of x is equal to the 1 when y is equal to the 0, or probability of x is equal to 0 when y is equal to the 1, and probability of x is equal to the 0 when y is equal to the 0. So we can do this differently. So one way I would call as a conceptual way. So let's do this conceptually. So what I'm going to do is I would like to find the intersection of the events, say when x is equal to the 1 and y is equal to the 1. So what does it mean? So how many events satisfy both of these conditions together? So a number, so output should be more than 3, right? Because y is equal to the 1. And output should be even. So there are two outputs which satisfy these two conditions. Like they are 4 and 6. 4 and 6, they are more than 3 and they are even numbers. So here, probability of, so y is equal to the 1 and x is equal to the 0. It means that there are so the number should be greater than 3, but an odd number. So there is only one output which satisfies this. It's 5. So here it's going to be, so the number should be less or equal to the 3, but it should be even. So there's only one number which satisfies this, it's only 2. And here the number should be less than 3 and an odd number. So there are two numbers which satisfy this, 1 and 3. So we can find the probabilities of this output using, again, the first table. So getting 4 or 6 is going to be equal to the 4 over 9. So getting 5 is going to be equal to the 1 over 9. Getting 2 is equal to the 2 over 9, and getting 1 or 3 is equal to the 2 over 9. So the sum of all of these probabilities is equal to the 1. So it means that our table, the joint probability distribution table, is correct. So at the same time, we can try to solve this problem more technically using so-called the conditional probability distribution table or the formula. So the second way is more technical, I would say. So we're going to use a lot of formulas, so more technical. So using the probability, using the formula of the conditional probability of A and B is equal to the probability of A given B multiplied to the probability of the B. So let's do this only for one. So for the first case, for example, so probability of X is equal to the 1 and Y is equal to the 1. It's going to be probability of X is equal to the 1 if it is already given that Y is equal to the 1 multiplied to the probability of Y is equal to the 1. So please note that probability of Y is equal to the 1 is very easy. We just need to go to the description of the Y. So Y is equal to the 1. It means that the output should be greater than 3, right? It's already given that it is equal to the 5/9. But the probability of X is equal to the 1 when Y is equal to the 1 is slightly different. So what does it mean, this probability? So an output, the output is already greater than 3. So there are only 3 options, right? Either 4, either 5, and 6. So we need to find the probability of this output is an even number, right? So we need to find the probability of X is equal to 1. It means that what is the probability that I choose one of these numbers and it's going to be even. So please note that this is not going to be just the sum of the probabilities for the 4, 5, and 6 from this table, right? Because if you remember, so we wrote down this description. It means that for all the outputs in this case, I got the total weights to be equal to the 9, and I have distributed this 9 to 1, 2, 3, 4, 5, and 6. So if I say, hey, so you can have only 3 outputs, 4 or 5 or 6, what is basically the total weight? So here the total weight is not equal to the 9. So the total weight in this case is equal to the, so what do you think? So the total weight here, so I need to distribute 2 to the 4, 1 to the 5, and 2 to the 6. So the total weight here is equal to the 5, and we've distributed this in this way. So I've got 2 of this 5 to the 4. So 2 of this 5 should go to the 4, 1 should go to the 5, and 2 should go to the 6. So basically, so when you have only 3 outputs, 4 or 5 or 6, probability of getting 4 is going to be equal to the 2/5. Probability of getting 5 is 1/5, and probability of getting 6 is 2/5. The thing is, like, whenever, even though we have only 3 outputs, even in this case, probability of getting an even number is higher than probability of getting an odd number. So basically, probability of getting an even number in this case is going to be equal to the 2/5 plus 2/5 is going to be equal to the 4/5. And we have to multiply this to the 5/9. So the answer is going to be equal to the, so we can just cancel this 2 5s, and the answer is going to be equal to the 4/9, which is the same as we solved previously conceptually. So we can try to do this for the other ones as well in the same manner. So the probability of X is equal to the 1 and Y is equal to the 0. In this case, we need to find the probability of X is equal to the 1. If Y is equal to the 0, multiply to the probability of Y is equal to the 0. So again, probability Y is equal to the 0. It means that the number is less than 3. Its probability is equal to the 4/9. Right? So now again, so less than 3, it means that the outputs are 1, 2, and 3. Okay, so what is the total weight here? So in this case, the total weight is equal to the 4. So we've got we give one of its weights to the 1, one of its weights to the 3, and two of its weights to the 2. So basically probability of getting 1 now is not 1 over 9 anymore, so because we have only 3 outputs. So in this case, probability of getting 1 is 1 over 4, probability of getting 2 is 2 over 4, and probability of getting 3 is 1 over 4 again. So if the outputs are less than 3 already, what's the probability of getting an even number? So in this case, it's going to be 2 over 4, right? So the 2 over 4, if we have multiplied them, so we can cancel them, it's going to be 2 over 9. And again, it's the same answer as here, right? So probability of x is equal to 1, y is equal to 0. So in the same manner, we can find the other probabilities as well. So probability of x is equal to 0. If it is given y is equal to 1, it's going to be probability of x is equal to 0 given y is equal to 1. Multiplied to the probability of x is equal, y is equal to 1. It's going to be 5 over 9 here. And this probability is going to be equal to 1, right? So 1 over 5. So the answer is going to be equal to the 1 over 9. And probability of x is equal to the 0 if it is given that y is equal to the 0, it's going to be probability of x is equal to the 0 given y is equal to the 0. Multiply it to the probability of y is equal to the 0. So probability of y is equal to the 0 is 4 over 9. So what's the probability that a number, an output is going to be odd if this is less than 3? So it's going to be either 1, either 3, right? It's going to be 1 over 4 plus 1 over 4. It's going to be 2 over 4. We can just cancel them. It's going to be 2 over 9. So basically, you can see that we can solve this problem using two ways, basically the conceptual way or the technical way. So sometimes when the description of the problem is not so clear for you and you don't know how to solve this problem, so maybe it's better for you to use the technical way rather than the conceptual way.